Hello everybody. We are going to record a video about one of the sessions. It is the second lab session based on the instruction from the university. We're going to try to talk about one of the sections of the lab. This is the lab 2, and especially we're talking about system calls. So here is the slides, and I'm going to do some sort of practical experiments based on the same environment that we have tackled in the first lab session. So here we have we are talking about the system call, and especially we're going to talk about read, write, and open. So as an introduction, we are going to do these things using C language. But before that, we need to have an information about some of the standard headers, or you may say the libraries, which is important to be included in the codes, because without these libraries, the codes cannot be run. So one of them is the unistd.h, which is a header file in C programming language, and it is provided access to the POSIX operating system API. And the POSIX is a family of standards specified by the IEEE Computer Society. And it is important also to know about the nanoprogram.c, and here we are going to use this instruction in order to have a sort of editor. It is a command line text editor that we're going to write the C language code in it. And we have later the GCC. This GCC stands for the GNU Compiler Collection. It is running the compilation, or let's say the compiler instruction on the specific code, i.e. we're going to compile our code using this GCC. Later, we need to have this a.out in order to show the output of our let's say code which is running in this lab session, the system calls. So we're going to start with write. This is one of the system calls, i.e. how to write some specific information to the screen or to a file. So the major let's say important syntax of this system call is this. We have the name of the system call, which is write, and we have some input parameters, including the FD. This is FD actually. It is an integer number, 0, 1, or 2, representing the source of input file, or let's say the source of the input file for the read. And here we're going to talk about the place where the data could be shown. So also we have this buffer, which is the content that you're going to use in order to be used for storing the data and then showing it up. We have this size t. This size t is shown here, and it is just like a data type for the output for this system call. It is also available in as a data type for one of the input parameter as well. So it is unsigned integer type used for this sort of functions, and it is a part of this unistd.h library. So let us start with one of the codes. So we're gonna write this code and try to see how can it could be executed. So going to the Ubuntu, so we are now in the terminal. In order to create file, or let's say in order to open a file, we're going to start with nano, as we said. I have already created a file. Even if you are not creating these files, you can just start with the same instruction, nano. For example, I'm going to name the my file with W, i.e. I'm trying to write something. It is something related to the write system call. So w.c means, here we mean by the C, it is a code written in C. So I have already written these things. Actually, the most important thing for this code is to have the uni std.h to be included. It is just like the import in Python when we say include, i.e. we are going to use this library or this header file in our program. This include stdio is not necessary for this part actually, but we're gonna use it later for some other instructions. So the only thing that I'm going to do is that I'm going to start writing the main. This is the main file, i.e. the main, you may say, class, which has a type of integer, and later we have two braces in order to brackets, sorry, to have all of the codes inside it. So here we have write as an instruction. It is the same thing that we talked about. So this one means we are going to write on the screen. This is an indication of the screen. And we have here the software. This software actually is nothing more than the input, i.e. this is the data that is gonna be stored in the buffer and which could be later displayed on the screen. Okay, so I have written this code now, and by the way, this /n or \n means that we are going to have a new line, i.e. just like an enter at the end of this text. The 8 here means that how many characters I'm going to show on the screen. So if this is 8 characters and you write 8, so the whole text will be appear on the screen. So in order to save the changes on this code, all what you are going to do is to have a Control and X. So pressing Control and X, it asks you to save the modified buffers or not. You're gonna click Y, i.e. yes, then enter. So when you press enter, you're gonna come back to the shell of your terminal. So now the w.c has been modified by the codes that you have written in. I'm going here to compile the current code. So what's the how to compile the current code? By writing gcc w.c. So i.e. the file w.c will be compiled by this instruction. So now it's being compiled, but still we can't see any output of this code. And in order to show the output, we need to write this ./a.out. This is the instruction that help you to see the output of this code. So by pressing enter, you can see that we have software, the whole characters in the buffer. Okay, coming back later to the same part in the slides that has been already uploaded to Moodle. What if I just change the software, let's say the size of the output to be shown on the screen from 8 to 5. So come back here and we're gonna try to modify the file. So how can I modify the file? You need to go to the editor. And where is the editor? You need to go to the nano, then w.c. And by pressing this, you're gonna come back to the same place, which is what we called it, the command line editor. So it is the same file. So I'm going to change this 8 to 5. So what do you expect the output to be? Okay, let's see what would be the output. So again, I need to save the modification by pressing Control and X, and then pressing Y, i.e. confirming the modification, and then enter. Again, I need to compile the same file again because there was a sort of modification happened on this file. Now, in order to show the output, again, I need to use this instruction ./a.out. And by having this, I can see the software, but the first 5 characters of it, i.e. not the whole 8 characters. So what does that mean? Means that by having this instruction, we are going to, let's say, take this amount of characters to be processed and shown on the screen, not all of them. So this is the whole buffer, this is the whole data that you have, but not necessarily all of them to be processed. So what is the size of the processed and the shown number of characters? It is this. You are specifying this the number of characters by this parameter. I just make it, for example, even more than 10. Okay. Control and X, and yes, and enter, and compiling it. So I now have a sort of problem or error. Actually, it is not an error, but it's saying that you are trying to present much more than what you have. So what does that mean? That means that the buffer that you have gathered information inside it has just less amount of characters or in it. So by printing more than that, sometimes it's just presenting a sort of garbage letters and characters, and sometimes it gives you a message like this. Okay, means that you are trying to printing out more than what you have. So this is just a simple practical session about these two codes.